Thank you for joining our webinar, our meetup, our chat session. My name's Jorn. I'm one of the solution architects here at NeuVector. And again, we're glad you joined. I got some housekeeping we will get to. And here are our attendees. I might put them on the spot and ask them to come off of mute in the order you see on the screen. Just say hello, give a little background of who each one of them are, and I'll do a little bit of house cleaning. We'll get right underway. So Ray, are you ready at the microphone, not microphone time?
Yes, I am. Hello, my name is Ray Lejano, and I am a field engineer with the Rancher Labs, now with SUSE. Besides being a field engineer, I'm also a release lead for Kubernetes for 1.21, and that's coming out in April.
Excellent. Thank you.
Hi, I'm Maury Cupid. I'm the director of pre-sales for Sonatype. I've been with them for about 3 years, and it's great to be here.
Thanks, Maury.
Hi, everyone. Tracy Walker, a solution engineer for NeuVector out of Denver, Colorado. Glad everyone can join.
So welcome. We did short introductions before, just a little bit more about me. Have had the pleasure of working at some really great companies. I think like a lot of you on the phone, I've got lots of other interests and family and all that good stuff. So really wanted to start out with, like, why are we here, right? I think Jorn's slide was the key to Kubernetes security. And when you step back and try to look at, well, why are we doing Kubernetes security? Why are we doing Kubernetes, right? Why are we here? Why are we building software? And over the summer and into the fall, when we think about software as a supply chain, we as a company have a tendency to think Edwards Deming and quote him. And one of his quotes that we actually didn't have until the middle of summer was this notion of, why are we here, right? Create a consistency of purpose and dedication to the improvement of the competitive position to keep the company alive and to provide jobs for their employees. In the end, if we're doing cloud, if we're doing software development, if we're doing marketing, if we're sending out Grubhub, in the end, we're trying to improve the competitive position of the company, keep the company alive. And what we'll look at is, as I'm shifting security left, as I'm talking about, well, we're building software, what are those components? We're keeping that in mind, right? Everything that we're doing is helping to reduce lead time, for example. So how are we doing it? Well, developers are getting faster and we're deploying applications faster, right? It's no secret. We're using open source software to build the applications, to build the infrastructure, right? 90% of the components that are in a modern application are open source components, right? And if you look at beyond Java, beyond NPM, and you start to look at an organization that has multiple languages, right? The number of components that are available becomes staggering. So if we look at Java and Maven Central and NPM.js and PyPy, we're starting to see more and more and more of these components downloaded. And what it means is when you end up with things like transitive dependencies, right? So I want this one thing and 1,000 other things come with it. I wish that were a joke. React from NPM is 1,000 dependencies. It becomes hard to manage, right? And managing at scale. So if we're thinking about, how do I shift left? How do I manage these components? How do I manage security? How do I get a secure application into production? It has to start with understanding that these open source components and the application that I'm building is a key piece of everything that I'm doing. And I can have one little component make everything fail in the end. Right? The difficulty with enterprises managing the dependencies is a lot of them just don't do it, right? Or they have a process in place and the process becomes this de facto standard for the outcome, right? So we're focused on DevOps, we're focused on whatever security process we're in. But how do I actually manage those components? How do I automate those tools? How do I deliver value to our customers faster, reduce lead time? And it's critical because when you start to look at this and push these applications out into production as fast as Ray is going to do that, right, in about 30 minutes, those applications end up with known vulnerabilities, right? They contribute to increases in breaches. 1 in 5 organizations in the last 12 months had an open source breach. The last 3 weeks alone, and I guess my news feed knows that I'm a security person, so I get a lot of the news. But whether it's SolarWinds or Microsoft or dependency namespace confusion, cybercrime is bigger than the drug trade, significantly bigger. So this is not going to go away. So what we do at Sonatype is we focus on everything that myself and Ray and Tracy are going to talk about. In the end, is supporting this notion of digital transformation, right? That digital transformation is, I need to increase revenue through competitiveness and higher quality applications and through faster product release cycles, right? That's what the whole next 2/3 of this is going to be about. And all of that supporting that digital transformation. So if I look at this from the open source component side, there are key groups that I want to help manage these open source components. So if I'm driving to increasing the revenue, well, I probably got to reduce lead time somewhere. I've got to reduce the overhead. So one of the first things that we do at Sonatype is help AppSec companies reduce the amount of time it spends managing these open source components or enforcing the open source governance policies, right? So we want to be able to have a series of policies that not only cover security vulnerabilities, but legal compliance, quality, right? Quality for us is I want to be alerted on components that are over 5 years old or that aren't popular, right? So having a system like the Nexus platform and the Nexus IQ server here, I have a hierarchical view of the applications, and the policies are inherited as you go down the hierarchy, right? So I can set policies at a corporate level that govern the open source components that I'm using, right? Not just telling me that, hey, you have bad components, but I can start to use these rules at different stages of the life cycle. One of the other things that we do is it's important to know that all of these policies, one size doesn't fit all, because every application might be a little bit different, or they might fall into groups or categories that we call them, right? So for example, a distributed application becomes subject to copyleft licenses that maybe an internal application doesn't. So you want to be able to tie those to the individual applications so that when you come down and create a policy for components that have a CVE score or a vulnerability with them, you want to be able to say, yeah, I want this to apply to all the applications, or maybe just a specific group of those applications. But I'm giving those teams a single place to manage the policies that govern which of these open source components that we're going to use. And as you might imagine, I've got a robust set of constraints here. I can do it on age, popularity, name, hygiene rating, all the things you would expect. One of the unique things that we provide in this automation is, what kind of actions do I take as I come out of these policies, right? So if I find a component that has a known vulnerability, it fails, maybe I want to do something different in a develop stage or a build stage where I'm not bringing the software supply chain to a screeching halt, right? That's going to increase lead time. But if I get into staging and release or am in production, I want to take different actions. I also maybe want to take different approaches to notifications, right? So if I want to look at licensing policies, I may want those licensing policy violations to go to a role or an email group. So I'm starting to automate the delivery of risk across the organization. So as we come through, we're looking at this and saying, everything I'm going to do from this point on to help make this application more secure so it can be deployed quickly, all is going to revolve around these policies, right? But those policies need to be in place so that each of the silos of their constituents, right? Edward Stemming says, break down the barriers between departments. If you've been doing this a while, you know this is actually one of the harder things to do. The application development team has different priorities than the security team that have different priorities from the infrastructure team. But you've got to be able to provide value at each of these stages when you're talking about the use of open source components, because they're at every stage. And people are touching these components, whether they're generating lists of CVEs or trying to remediate. So we're going to look at a couple of these. We're going to look at the view from application development, application security, and quickly into legal and compliance. And then I'm going to let Tracy cover the ops and the cloud infrastructure on that side. But one of the first things that you want to be able to do in order to help these teams is have a central location where I can actually give them views into the components that they're using, right? Into views of the risk. Now, GitHub and GitLab and the source repositories, whether it's Azure DevOps, you're starting to see these platforms become the location, not just for developers anymore, but all the members of the team might come into GitHub to find data around those, the tests that are run. If I'm in Azure DevOps, looking at pipelines. But one of the things that you want to do is provide all of those teams with a common view. So from within the source code repository, actually be able to come in and say, okay, for this application, what does the evaluation look like? Right? What are all the components that I'm using in that? What are direct and transitive? What are the policy violations? So from a single place, I can have the security team come in and look at a view of all the vulnerabilities, kind of an any pattern for us, but security people like lists of vulnerabilities. So as we come through, providing that view so that no matter what role I'm in, I have that common view of the environment, right? So that's true of whether I'm doing this within my source code repository, or maybe I'm doing it within my pipelines, right? So I'm automating the evaluation that's happening. I'm providing that same visibility into the pipeline. So no matter where, again, no matter who you are, you're having the data right where you end up using it, right? So if I link out to this report, it goes out to the same report we just saw. So now I'm just going to dive into each of the individual silos here, and folks on the call, make sure I stay on track on time. I'll take up all 3 hours. But so as we come in, let's take a look at the development side of it. If I'm trying to make my application deployments more secure, the cheapest, quickest way to do that is actually at development time, right? So, but I have to give the developers the tools that they need to actually reduce the amount of time it takes to research and get approval for open source components, while providing them the ability to remediate and all the information they need on the remediation side. So again, if we come back to my goal is to deliver value to my customers so we can have competitive advantage, keep the company alive, and keep jobs for myself. The first team and the only team that actually can remediate these problems is the development team. So one of the first things that we're going to do is find ways to help them reduce that amount of time, right? So our customers are looking at this and saying, well, because we've implemented the Nexus platform, our developers have reduced the amount of time spent on the rework by 40 to 50%. Teams are automating the delivery of an open source component. You probably think, well, anybody can go online and get an open source component. Well, enterprises that have a strict policy in place, the developer has to go request a component. There's a 6 to 8 week lag time. I don't know why it's always 6 to 8 weeks, but it's always 6 to 8 weeks when it's manual. How do you automate that, right? How do you deliver these components in near real time, right? So let's take a look at the developer's view, right? So if I'm in GitHub and I have that view, and if I'm in my IDE or I'm in my build tool, I'm providing that developer views into what are the open source components that we're using, right? What are some of the things that I can do to remediate? Now, I'm actually going to come back to GitHub. In this case, my team uses GitHub. We saw the link to the component evaluation. But there are times you want to also automate remediation process, right? So being able to look at automated pull requests as an evaluation happens, identify all the open source components that are in my application, and then create a pull request that allows the developer to have the details around this version upgrade. Right? So from here, I can say, well, I'm in 2.7 of a log4j. It says I can go to 2.13.2. Here's the CVE that was in place. It looks pretty straightforward. And I'll use, as a developer, I'll use this as a starting point for my remediation. Now, I could come in and say, yep, I'm going to go ahead and merge that. But again, the developer has a unique perspective into the application. We know that log4j is a framework in itself, and maybe I'm using other components. In fact, I know I'm using the log4j API, and I want to keep those versions in sync. But this is a great starting point in automation to let me know, okay, this is a component that I can easily fix. Right? My goal is to get the components that I'm using to pass the security policy violations so I can get this into production quickly. So inside the IDE, the developer has another view, right? This is the view that they're used to, whether it's Visual Studio Code, Eclipse, this is IntelliJ. But on the left-hand side here, I've got a list of all the open source components, direct and transitive, that are in my application. And a lot of the success our customers have is just getting this visibility into what's actually in the application. So we'll make this look a little bit simpler, right? Because I've got a ton of red here. And for applications that have never been evaluated before, this might be the case, right? We're not adding a new component and we notice that one thing is red. We're actually going to get rid of most of the red here in a second. But for applications that have never been evaluated, this is a common view. The application I have here is actually the Struts2 reference application that everybody knows about from our credit bureaus in the past. But it's still here. People still download it. People still download thousands of versions of the Struts2 components that cause that. And it's not just for research. It's because companies don't know that they're using it. So I can come in as a developer and say, look, I'm going to focus on the direct dependencies. These are the things that I can control. I'm actually going to do almost all of my remediation here in the next couple of minutes without looking at a list of CVEs, right? As a company, we're focused on the components itself and how does that component that I'm using fit in terms of policy for my organization. So let's go to our Log4j core 2.7. The IDE says I should go to 2.13.2. That's great. It lines up with what the automated pull request says, but I get a little bit more data here, right? Down here on the bottom, I actually have every version we know about and how every version of Log4j core compares to the policies that I have in place, right? That I said earlier. So I've got popularity along the top. I can see, again, what are the most popular versions. I've got, are there breaking changes? So we're not going to tell you, hey, these are exactly the breaking changes that occur, but it's giving the developer a level of effort, right? So from here, we go from 2.7 to 2.8. It goes from blue to red. Well, if you look in the kind of in the background, there are 86 changes that happen between those two versions. There's about 100 changes between 2.8 and all the way through. So there's a significant level of change, but often the breaking changes or the changes that occur in an API at the API level they're very slight. But when they do break, they break 100% of the people that are using it. Right? So you want to have some visibility. But for every version, also, what are the security policy violations? What's the legal policy violations? So I'm using this remediation engine not just to say, hey, what's the next version that doesn't have a vulnerability in it? I'm saying, what's the next version that passes my policy? Right? So 2.13.2 happens to be the first one. I can click on it, jump over, see the details. We'll go ahead and fix it. So we'll click on migrate to selected, and it'll update that version. And if I look in the log in the pom.xml, the manifest file, we'll see that it indeed upgraded to 2.13.2. Now I could have again merged that pull request, but I mentioned, well, maybe I do have another component and I want to keep them in sync. So the automation says there's really nothing wrong with this component. Actually, there's one slight thing. It's 4 years old, but we're not going to break a build over it. But I do want to come in as a developer and let's just keep everything in sync and change that to 2.13.2. Right, so I'll kickstart Maven here. We'll reevaluate, and automatically we start to see the list get smaller here. I want to give that positive feedback to the developer as they're fixing these components. Again, I'm not looking at lists of vulnerabilities. There was a vulnerability there, but I don't really care what that vulnerability is. I want to use the best component for the job. Now, we talked about Log4j being a framework. The big framework that's in here is Struts2. Right? So we see a couple of Struts2 components that have policy violations. We'll select Struts2 core here. And there is a version I can go to, 2.5.26. Again, all the details I have around the components. 2.5.22 is pretty popular, but it still has the policy violation associated with it. This component's 4 years old. So we'll jump to 2.5.26. Now, a lot of other vendors in this space really tout the automatic remediation, and they'll say, okay, that's great. We can go to 2.5.26 or we can go to 2.13.2. But the reality is it's really more complicated than that, right? So if I come in and say, yep, I'm going to go to 2.5.26 and I'm going to click on migrate to selected, it's going to tell me that, well, we can't find what you're referencing 2.5.10 because these manifest files, they take variables, right? If I had to come in and say, with the framework, I want to set the version number at every place that it needs to be set, or I can set the version of the framework that I'm going to use up here. So here's a perfect example of there are vulnerabilities here. There are policy violations here. If we were just looking at a manifest file, we really wouldn't know that. Right. So we'll actually come in and change this to 2.5.26 and we'll save that. We'll kickstart Maven here. We'll do another evaluation. And while I'm doing that, we'll come back and see, well, really, what does that mean, that whole manifest scanning? Well, some views that GitHub is a perfect example. Some views have a limited view when they're looking at the dependencies because they're just looking at the dependencies that are in the POM file in this case, or the package.json. They know, hey, these are all the components that you have specified. But if you come down to struts in here, they actually don't give you a version number, right? Because they don't know where that version number is. It's harder to automate that process. So by using a solution that just looks at the manifest file and doesn't look at the application itself, you're really limited to the views that you have and the data that you have. But because I'm sitting here, downloaded the application, evaluate it, having Maven pull in the components, I know exactly which version that we're using here, right? So I didn't start Maven well enough here. So as we come in, now my version's upgraded 2.5.26 and get a little bit less red here. I've got a couple of key components here. We're gonna fix this. Actually, in the end here, we'll look at the REST Struts 2 REST plugin. I said I wouldn't look at all the a list of vulnerabilities, but I will actually look at one of these components and the vulnerabilities there, because there are some times where the recommended version doesn't exist, right? That vulnerability carries with the component all the way through its life. Now, when that happens, I want to be able to have the ability to take a look and say, okay, well, why can't I fix this? Well, I can't fix it because there's a CVE here, 2018-13-27. I'm going to hold off. I'm going to have my team help me decide and work on this. So I think I've gone about as far as I can on this component. When we actually look at the CVE, we'll find that it's a config option, and I can actually remediate it through a config. I don't have to force an upgrade or work around. But remediation often is not as easy as upgrading to a specific version. I have to do something around the code. So we'll leave this here. We know that 2.5.26 in the bigger picture of the framework is the best version to use. Again, I don't want to start separating versions of those. So that leaves one other piece, iText PDF 5.5.6. There's no recommended version available for this current component. Why is that? Well, I mentioned we have different policies. I have a security policy, but I also have legal policies in place. And because I know this application is distributed, I also know that the license that the Nexus platform has found is on the license banned list. So I actually have a number of policy violations. Well, two. I've got the license banned, right? So there's an AGPL 3.0 license, which is not a great license to have in place. And then I've got a security vulnerability. Why do I care about this this license? Well, iText PDF is a great PDF engine. It generates PDFs. The company decided they wanted to make money on this, so the PDFs are watermarked. If they found them outside, right, distributed, they become part of this copyleft license, and they want to be paid for it. So a lot of my customers run into this component specifically. right? Because we'll see why here. A lot of folks don't know that they're really using it or this version of it. But let's go ahead and fix it on my side real quick. So we're going to come back to this. It says I have no recommended version for this. Now, what's happened in the background is the policies that we had in place, right? If I come back to my policy engine and I had this license ban policy here, I said, hey, if I see these policy violations, don't really care about the warn or the fail, but I want you to email the legal team, right? So immediately the legal team gets an email about this specific the component, and then they're going to come in and say, hey, have I paid for this? Can I validate this? They'll have a separate view. And as the developer, I know, well, for legal policy violations, I need to have that resolved by the legal team. So does that mean I stop here? Well, no, because I'm providing the developer all the information they need to actually build a better, more secure application. The developer can come in and go, okay, well, I can actually get to 5.5.12 without a security violation, but I still have the license. That's okay. So, well, let me actually come in and select 5.5.13. It seems to be the most popular. So when legal comes in and approves this or doesn't approve it, I don't have to come back and fix a security vulnerability that I already know exists. So let me select that. So we'll go through the same process. We'll select it. We'll look at migrate to selected. And we have this weird message that says it can't be migrated again. Well, this is again, the complexity around remediating through versions is, no, we never specified iText 5.5.6 in my POM file. We actually specified com.lowerg iText 4.2.2. So when the company decided they want to make money, they rebranded and reversioned. And the Maven Central, which is where the creators and stewards of Maven Central, with 260 billion downloads last year, part of the mechanism is if the owner of that component wants to change the name, we're going to deliver the newer component, right? So as we built this application, Maven came in and said, oh, you want this 4.2.2? Well, in reality, it's 5.5.6, and here's that version and bring it down. So the developer really didn't need to know that, right? So I can come in and we'll go ahead and upgrade to the latest for demo purposes. I just copied it here. Again, we'll see the complexity in those other systems that are just looking at the policy or the manifest file, right? Here, again, GitHub says you're using iText 4.2.2. Well, when we build the application, it's going to be something else that's in there. It's going to be that iText PDF. But because it doesn't know anything about the application that we build or the container that we build for that, it's just going to blindly say, hey, you've got this. And it's going to base any of its security alerts on the versions it sees in the manifest file. All right, so let's come back. We'll save our file here. We'll do our little kickstart here. We'll keep a time check, about 10 minutes maybe. So as we look at this, we now will go in and have 5.5.13. I only have one red component here. Now, what can I do? Well, now that I've fixed that, the second red component is our license, right? So let's put the hat of the legal team on. And we came in and we looked at my organization here. I'm going to log out and log back in as a legal person. And here I can have customized views based on the policies that I care about. So as a legal person, I really care about just the licensing policies. So when I come in, I don't need a full list of all the vulnerabilities and all the policy violations. I need to know the things I need to work on now, right? So I can come in, select that component. I can actually see what evaluation it's been in. And then if I want to come in and say, okay, we need to buy this or we bought it, let's add a waiver. We'll add a waiver to the application itself. If we're going to buy it for the organization, for example, or license it for the organization, I can set that up for a sub-organization or the entire company or all the components and all the versions. It usually takes about 14 days to get the new version, and we'll just put in buying here and we'll submit it. Now, as the legal team, I've put in this time-based waiver. I want to make sure that I'm legal. So if I don't get it within 14 days, I want policy violations to occur. Right. So if we come back to our violation details now, we know that there's an active waiver there. Right. If I come back into my applications and start to look at the individual components as we come in, right? Me as a developer, I'm still continuing to work. Right. I want to be able to have these components, but I also want to come in and make those changes in the evaluation at a later time. Right. So I've got all my components. The other component's going to be waived, and we'll see where that comes into play here in a second. But as a developer, what I end up doing is, if I fix these components here, I actually want to create a new branch for these changes, and I already have created that. So we're going to check out this thing. Stash Git is really good at helping you not blow stuff away. So we fix back over. I would do a Git push over to GitHub. And then if I look at GitHub again, one of the things I do with that new branch is create a pull request. So I've done this before. I have my pull request that's associated with that branch and the changes. And what the Nexus platform has done is this is going to be the place where we talk about fixing these components and the evaluations that occur in the components, right? So I want to come in, I want to do another evaluation on the application, rerun it, right? I want to be able to see new policy violations that exist. I haven't done another evaluation, so I still have my license is not approved, even though I've got it waived on the report side. And then coming in and see, well, these are transitive dependencies, but I'm putting everything into the pull request. The things that I fixed, the things that I haven't been able to fix, a comparison between what's in the default branch and what's in the PR branch, right? So as I come in, being able to see based on the work that's done. So everybody on my team can now comment on the fixes that I've made, right? And moving forward, continue to build the best product and provide the data around it, right? So when we come in, we want to be able to see the reports. We want to be able to evaluate. Now that I've done the evaluation, I've upgraded the component. I've done an evaluation against the older version of that. We'll notice the policy violation for the license is not there anymore because we've actually commented or we've waived it, right? So we're getting all of the teams working together in order to build the better application and fix the application in deployment. Now, we'll get a lot of pushback from the development teams about, oh, it's next to impossible for me to upgrade components. Yeah, when you don't have a visibility into what those versions are and how you can get from one version to the next, right? And how I can understand which components have breaking changes, which components do we think the entire project might be exemplar or laggard. So without that visibility, of course, it takes a long time because you actually have to come in and look at a list of vulnerabilities. If we look at and we got through fixing this problem, if I take the developer or the security view of this and just give the developer a full list of CVEs, this is painful, right? Are they going to have to go in and provide data and information about each of the CVEs? Well, if you're insistent upon shipping a list of CVEs, we have to make sure it's valuable to them, right? So even when we're building this, we're the first company to have a human curated data research team. It's about a third of our engineering team are all data researchers. So we build on not just the description from the CVE, but they were tasked with, okay, build on the explanation, give the developers an explanation that helps them fix this. Are there recommendations and workarounds? Right? Again, not all the time can I just upgrade to a version and the vulnerability goes away. but how can I actually prevent maybe new vulnerabilities that have the same type of attack, right? What can I do on the recommendation side? Are there existing attacks? So giving the developers all the detail they need around these components, but still giving each of the individual silos the visibility and the view that they want to see. The legal team maybe wants just a report of all the components. They want a list of the licenses that are associated with it and the security issue. And trying to give the teams the information that they need. And my whole drive is not to give the developers a list of things they have to fix, but help the developers fix this as quickly as possible. Now, keeping track on time, I've got about 2 minutes. What we're going to see is this application deploys as a Docker file. Some of the things that we could do on the left-hand side to help Tracy better have better containers on the far right side is we can incorporate that visibility into the open source components that we see at the OS level, right? Even before we push it to our registry, right? We're able to evaluate the containers that are in a registry. Hey, show me all the things that all the vulnerabilities that might be in that OS level. Or I could actually come in further left and say, well, as I'm building this, don't even build it or push it if I actually have policy violations. So using that and extending it beyond just the application layer, but the Docker side of it, right? Our philosophy on the left side is I don't want to keep feeding bad stuff downstream. Right? Fix the problem early. If I can't fix it, give the teams everything they need to know to mitigate the risk. And then, as we'll see with NeuVector, look at the application and the behavior of the application as it's running to see, hey, do I actually have any vulnerabilities that haven't been caught, right? So again, when we come back to this, it's all about that notion of providing not only the application development teams with the data they need, but that security team, reducing the amount of time spent looking at code quality and looking at the possibility of a breach. One, because they don't know all the components that are there. Again, they're focused more on the list of vulnerabilities. But if they don't have to review lists of vulnerabilities and figure out what to send to the developer, and they're giving the developer all that version information, it becomes more powerful, right? And then we saw how we could help the legal team facilitate the use of a component or the blocking of a component based on their expertise, right? I want to be able to reduce the amount of time that's spent there. And the last thing that team might want to do is if I come in and have a broader view of that, maybe I want to take a more portfolio view of all of the policy violations, or finding that iText PDF in all the applications that I have deployed with a single click and the risk associated with it, right? Or take a look at an application point of view. If I'm looking at adoption and quality and performance across my organization, I want to see more of my project teams scanning and evaluating further to the left and having the developers fix the problems early in the process, and really having this view of, well, how am I doing against this digital transformation effort, right? So the last piece of it, and I'll leave to Ray and Tracy around how do you find new vulnerabilities? How do you find new compliance problems? How do you find new risk on that far right side of it, right? So hopefully Ray is going to take my better built application, deploy it out into the wild, and Tracy's going to capture it. So I think at the end of this session, we have individual webinars. So if there are questions, we can join that webinar later, but I appreciate the time.
Thanks, Maury. Unless I am mistaken, I have the talking stick ready to hand to Ray. And Ray, if you want to take it away, you can steal the stage from me as you feel.
Sounds good.
And just a housekeeping note, folks. Maury's not allowed to leave. So if you have questions for him or any of our panelists or anybody, drop that stuff in the QA here on that Zoom meeting. We appreciate it. We'll keep an eye on it. Thanks.
All right. So I hope you guys could see my screen.
Good
so
to
I'm
go,
taking
sir.
Sounds good. So I'm taking the handoff from the developer side now to the operator side. So how do we deploy this container image of the that's built from the Docker file of the application with the remediated CVEs from Sonatype? Just to remember, my name is Ray Lejano. I'm a field engineer with SUSE and Rancher. I'm also Kubernetes release lead for 1.21. So this talk is all from the operator side and how we leverage Rancher Labs' flagship product called Rancher, which manages Kubernetes everywhere, and how we automate security. So first, we're going to briefly go over what Rancher Labs and what Rancher is, since this is a NeuVector lunch and learn. So this might be the first introduction for many of you to Rancher. Then we're going to go over on how to automate security in Kubernetes clusters. Then we'll do a little demo on how to do that. A little bit about Rancher. Rancher Lab started in 2014 from the same team that started Cloud.com, which was later acquired by Citrix. In 2016, Rancher launched an agnostic container orchestrator. So we didn't just manage Kubernetes, but we also managed Docker Swarm, Mesos, and we also had our own container orchestrator called Cattle. That time we had about 1 million downloads. But in 2018, Kubernetes became the de facto container orchestrator leader. So we moved to a 2.0 version of Rancher, which only supported managing Kubernetes. And Rancher itself was built on top of Kubernetes itself. In 2019, we released 2.3, which we have over 100 million downloads and 30,000 active deployments. In 2020, you might have heard, we were acquired by SUSE in December. We also launched Rancher 2.5, which includes out-of-the-box continuous delivery, which we will leverage in today's demo on how to automate security along with your applications. What Rancher is, if you don't know what Rancher is, it is a Kubernetes management platform, and it is about managing Kubernetes everywhere in the data center, in the cloud, and also at the edge. Rancher Labs has several products and projects. Briefly go over the differences between products and projects is that we offer support and service level agreements for our products. Rancher, which is the flagship product, is a Kubernetes orchestrator and management platform. We'll go over, we also have 3 Kubernetes distributions. They're all CNCF certified. We'll go over these a little bit later. We also offer a lot of other CNCF projects called Longhorn, which is a cloud-native persistent block storage, which we donated to the CNCF. And later in the demo, we'll also leverage Fleet, which is GitOps, which is the continuous delivery tool, and that is built into Rancher 2.5. We also have other open source projects like Rio, which is a micro platform as service, which is another layer on top of your Kubernetes cluster to easily deploy like DNS, HTTPS. K3OS, which is a Kubernetes operating system, which is purposely built to simplify Kubernetes operations. So uses very low resources, installs fast, and boots fast. Submariner, which is a cross-cluster network connectivity for Kubernetes, enables direct networking between pods in different Kubernetes clusters, either on-prem or in the cloud. And our latest project is Harvester, which is a hyper-converged infrastructure. It's built using Kubernetes and KubeVirt and Longhorn, so you can deploy and manage VMs on-prem using this open source project. So going over some of the Kubernetes distributions of Rancher Labs, we have 3 of them, RKE, RKE-Gov, and K3S. They're all 3 are CNCF certified. That means that there's no vendor lock-in, so you can move your workloads between any CNCF certified Kubernetes distribution. We also offer a rich API, so you can automate your tools using Rancher's rich API or the Kubernetes API itself. And one of the points of having these 3 distributions is that we could make bootstrapping Kubernetes easier, even in an air gap scenario. So there's some of the differences between the distributions. RKE Rancher Kubernetes engine is dependent on Docker, but we are slowly moving away from Docker to other container runtimes, which RKE is leveraged by Rancher to bootstrap Kubernetes clusters from the Rancher management platform. We also offer a FIPS compliant and hardened RKE Gov, which is a CNCF Kubernetes distribution, which uses Containerd. And we also offer a lightweight, it's under 100 megs, it's Kubernetes distribution called K3S, which is great for the edge and IoT. Now let's get into Rancher before we go into the demos, since some of you may not heard of Rancher before. Just why Rancher? Rancher is purpose-built to manage Kubernetes. We're open source, and all of our products and projects are all open source as well. So we're big on open source. We're not opinionated, so we are based on upstream Kubernetes. So like I said, you could move your workloads anywhere from the Rancher managed Kubernetes clusters. And we're recognized by Forrester and other organizations like Gartner, Hypecycles, and Firestarter as well. So if you're new to Kubernetes, I'm sure most of you are not, what you need to unleash the power of Kubernetes, you obviously need a Kubernetes distribution, either in wherever you're running your workloads in the data center, cloud, and on edge. And you need some sort of central management and how to globally manage your cluster operations. How do you globally manage RBAC, and how do you manage users accessing your clusters? So we have the same paradigm, but with Rancher, starting at the bottom, we do have those 3 CNCF certified Kubernetes distributions with RKE in the data center and also RKE Gov. We have tight integrations with cloud providers, so we could provision EKS, AKS, and GKE clusters as well. And of course, we have our lightweight just CNCF certified Kubernetes distribution called K3S for the edge and IoT. But now we have Rancher to manage all your Kubernetes distributions and all your clusters. And with Rancher, we could provide things like version management, so you could upgrade and roll back your Kubernetes versions as well. We provide easy integrations with monitoring and diagnostics and logging. And so we leverage upstream open source projects for that. You could integrate with your enterprise IDP, like with AD or any SAML as well. And you could manage global RBAC policies with those IDP groups and users as well. You can enforce policy. We have tight integrations with OPA Gatekeeper and also with SIS benchmarking. We leverage Kubench from Aqua Security. And we leverage Prometheus, the Kubernetes stack, and the Bonsai Cloud logging operator for logging, which uses FluentBit and FluentD. So we offer also on what I call day 2 operations. And these day 2 operations are easy to deploy with just a few clicks, and we leverage Helm to deploy those applications. So like I mentioned before, monitoring is from Prometheus. We also include Grafana Alert Manager leveraging the Kubernetes stack. Istio, just a few click this deploy for Istio for service mesh. We also offer Terraform providers as well. So you could easily bootstrap a Rancher and with our Terraform providers. And the top tier here, once you have your full stack of your Kubernetes cluster itself and something to manage your Kubernetes clusters, like with Rancher, then you could deploy your containerized and execute your containerized applications. So what we're going to use to automate security, we're going to leverage Rancher's continuous delivery. So this is a new feature in Rancher 2.5. And with continuous delivery, it uses our technology called Fleet, which is just GitOps. When with Fleet, you would store all your Kubernetes manifests, your Helm charts, your manifests with customized overlays in a Git repo. Then you would group your managed clusters, your managed Kubernetes clusters as cluster groups. Our Fleet manager pulls the contents of the Git repo, and there's a cluster agents on each cluster that will pull from the Fleet manager itself. So if there's any changes to your Git repo, like if you were to change your Kubernetes manifest to use an updated container image tag, it will update those changes downstream to your managed Kubernetes clusters. So just to summarize, Rancher manages Kubernetes everywhere in private cloud, public cloud with GKE, AWS. Also on-prem as well, we do have a node driver that will integrate with vSphere. So you could actually launch VMs, and once it launch VMs, it will deploy Kubernetes inside those VMs. We also offer a feature that if the kubelets in those Kubernetes clusters do not reach back and say hello to Rancher, it will auto replace those VMs and deploy a replacements VM, and also and then bootstrap Kubernetes on top of that as well, and move your workloads to that new worker node. This is just a screenshot of the UI that we'll go into. This just shows you how Rancher on a global cluster view manages Kubernetes in Amazon AWS, DigitalOcean. This is GCP, and also we provision a Google GKE cluster as well. We'll also provide some lightweight, some monitoring as well from the main dashboard, and also further monitoring stats once you actually go into a cluster. Easy links to Grafana as well, and provide some metrics from Prometheus. So now let's talk about security on Kubernetes. So you're here because of NeuVector, and with NeuVector, Trace is going to talk about in a little bit. There is a discover period that you need to have to identify your application's behavior. And then you use NeuVector's monitor and protect mode to secure your application. So we could export NeuVector's learning of the application behavior to create a security policy in a custom resource definition in a CRD. This CRD is our security as code. So we're going to leverage this CRD and Rancher's continuous delivery to automate and maintain the runtime security policy using both Kubernetes, NeuVector, and also with Rancher. So when you deploy a new cluster, this is now secure. When you deploy a new cluster, you manually deploy the application and the related NeuVector CRDs for its security policy. But in the next slide, we'll go over high level, and then we'll go over in the demo as well, how we're going to use Rancher's continuous delivery to enforce the global security policies across all your managed Kubernetes clusters using NeuVector and the NeuVector CRDs. So leveraging Rancher's continuous delivery with Fleet, here we will use this to automate the global security policies across the multiple Kubernetes clusters using these CRDs. So Rancher, of course, orchestrates Kubernetes, while Fleet is the Rancher Labs technology that is used for GitOps for the continuous delivery. So in a Git repo, we're going to store the Helm charts for NeuVector and customize security policies for your application, which we're going to go over in the demo. And those security policies are going to be CRDs. That's created after the discover learning period in NeuVector. So at first, we create a Kubernetes cluster. Then we are going to leverage Fleet to deploy our application. But when we deploy our application, NeuVector and any CRDs for the security policy for the application will also be deployed to that Kubernetes cluster. So when we actually deploy our application, it will be secure already. And then so when we deploy new Kubernetes clusters, or as they're created or as they're imported into Rancher, Fleet will drive the application deployment to all the new clusters or specific clusters as well, using grouping with labels. So Fleet will deploy NeuVector and those security policies with security as code as CRDs for the application to the clusters based on these cluster groups if we group them by cluster by label. So before I go into the demo, there are opportunities to learn more about Rancher. We do have a YouTube channel, which we have Kubernetes master classes, the previous ones hosted on there. We also have ongoing Kubernetes master classes for very specific topics. It might be on Istio, it might be multi-tenant monitoring with Thanos, or might be Prometheus, or moving or migrating to the newer version of Prometheus. So we do have the YouTube channel available. We also have a Rancher Academy as well. It's free to learn on how to be a Rancher operator. And we have almost weekly rodeos, which are about a 3-hour hands-on workshop. So you'll actually get virtual machines to deploy Kubernetes and to deploy Rancher and to deploy an application as well, and to provision a Kubernetes cluster from Rancher as well. We also have developer-focused rodeos as well, and those are best practices on how to create Docker files and how to build your application into a container image and how to push it into a registry like Docker Hub. And upcoming in May, we do have a SUSECon, which showcases some of our technical content, and I'll be giving a talk on it about Kubernetes upstream. And there's upcoming changes in Kubernetes that I'll talk about. It's going to be the deprecation of pod security policies and upcoming in April, in a few months, but it won't actually affect end users until 2022. So I'm going to go into the demo, but towards the end of the deck, there are some Rancher resources listed out here. All right, so actually, let me go out of presentation. So this is Rancher, and this is Rancher's global cluster view. So we see here, we're managing several Kubernetes clusters, mostly on Amazon, and we have one on GCP. So the goal of this demo is that we're going to leverage GitOps to deploy NeuVector and our Struts application to a brand new cluster. So before that, we had to use NeuVector to learn about the application. So I hope I'm not stealing any thunder from Tracy. So before we did this process, we used NeuVector to learn about the application here, Struts. Then we exported. I don't know. Let me see if I have the password here. Then we exported those policies, export policy group, into protect mode. So we've done this before going into deploying the application and deploying NeuVector into, let's say, a production cluster. So we've done this work that Tracy might touch into in the next segment here. Now we have a new cluster with AWS deploy secure Struts here that we want to deploy NeuVector and the Struts app, but we want to make sure those NeuVector CRDs are also deployed, and that it's in protect mode, so our application is protected. So I'm going to go into the Cluster Explorer view into Rancher. So this just gives us a Kubernetes-Native view of our cluster. I'm just going to do a brief tour here of the Rancher UI in case people are interested, but we can always talk about this in the Zoom session afterwards. We could toggle between our clusters on the upper right, and we have our Kubernetes resources on the left. We could also manage custom resources as well. So this is a brand new cluster. We're going to go into Rancher's continuous delivery. First, we're going to take a look at our clusters here, and want to point out that we could group our clusters using cluster groups. So we do that with labels. So our goal is that this is a new production Kubernetes cluster, and we want to deploy our secure Struts application with the NeuVector and with the NeuVector CRDs. But before we go into that, let's add this to a cluster group. This deploy secure Struts. All this is a label on the cluster. Label deploy equals secure Struts. So I'm going to go back to our cluster, take this, assign it with that label. Then we're going to go into our Git repos. So like I mentioned before, how this continuous delivery module takes the contents of any of the Git repo and deploys it to a single cluster or a group of clusters or to all clusters as well. So we have options. What I'm doing here is just using the group by clusters for this demonstration. I'll walk through the repo itself. So I have a NeuVector meetup repo. What we will initially deploy is this NeuVector core init, which is just creates the namespace for the NeuVector core. We also have our NeuVector Helm chart that I will deploy, and we have our application. we have two versions of our applications, secured struts and struts. Struts is what we used initially to deploy the application, where it's just a basic create a namespace, create the deployment for the application, and create a service to expose that application. What we're going to deploy in production is secured struts. With secured struts, it's almost the same. It creates a namespace, but before we create that deployment, we create the with that NeuVector security role for struts in protect mode. Then we create the deployment for the struts application and the service to expose that application. So I have everything set up here. So we're going to use these three repositories: prod NeuVector core, prod NeuVector init, prod secured struts app. Ideally, we would have the init phases tied in with the NeuVector core Helm chart, but I didn't have time to do that dev work. So what we're going to do, I'm going to show you the configuration, is that we just point out the Git repo with branch and a path to it as well. We could deploy it to no clusters, to a single cluster or cluster groups, or to all clusters. We're going to use the groups option here. So meaning that any new Kubernetes clusters that has the label will be deployed the contents of this Git repo. So we're going to take a look at this to see if it worked. And we have deployed a namespace and some secrets. So now I'm going to deploy the struts application itself. Edit config. Deploy it to the cluster group. Like I mentioned, you could do it to all clusters. So whenever a new cluster is provisioned, it will automatically deploy a NeuVector. Save it. This will take some time because it's 23 resources. So we'll just hang out a little bit here, and we'll see the progress. In the meantime, so it is deploying the application to the brand new Kubernetes cluster called AWS Deploy Secure Struts. And I'm going to take the time here to go back into what we're going to deploy next is the secured struts. That you're not just deploying an application manifest, you're also deploying the NeuVector security rule as a CRD for your application. So that whenever you're deploying an application via Kubernetes manifest, now you could actually deploy it with those NeuVector security policies. So this usually takes a few minutes. So I'm just going to take a look at see if there's any questions that I can answer. If I could find the questions page.
Nothing coming in on QA yet there, Ray, but we'll nudge you if there is. And I have to wait for the darn cloud to spin stuff up for us. Hurry.
Yeah, it always takes a little bit. There's 23 resources. As we see here, is pointing to one cluster. It's not ready yet, so it's almost there. In the meantime, I'm just going to kick this off anyway. So even before the NeuVector is ready, so we will have our application up and running. But we'll also have that CRD ready as well. So ideally, we'll just wait a little bit to see. Let's see. It's always the controller pod that always takes a little bit of time. All right, so that is now done. So now let's deploy the secured struts app. Like I mentioned, it's not your normal Kubernetes manifest. It includes that NeuVector CRD. So we're going to deploy this. This should be fairly quick. All right, wait to apply it, and it's ready. Like I mentioned before, if there's any changes in the Git repo, Fleet and Rancher will update the workloads in your managed Kubernetes clusters with those changes. So if the struts app is using a newer tag for the container image, it will update any workloads in your managed clusters. This usually takes a little bit. All right, so let's wait. So it's now nice and ready. So let's look into what that launched. We're going to go into our cluster. So we do have our pods. So we have our struts app here in the struts namespace. With Kubernetes, with Rancher as well, I could manage those custom resources. So we see the custom resources under more resources. So we see the NeuVector security role for struts. Now let's look into services to see how we can access our NeuVector application. So it does require HTTPS. I'm going to change this. Accept it. Nice welcome screen since it's a new install. All right, now I'm going to go into policy. It hasn't refreshed yet. It might take a little bit of time, but shortly we should see the protected application under groups. Let's give it a few more minutes. If not, I'll hand it off to Tracy, and you could always come back on the follow-up Zoom call here. Refresh. Always takes a few minutes for it to show.
Yeah, you may need to apply the license also to.
Oh, okay. Let me pause my screen share and send. And I am resuming share. And
There you go.
see the Struts app should update to CRD anytime soon. If not, I'll just hand it off to Tracy and we come back to it on the follow-up Zoom in a little bit here. So.
Yeah, Ray, maybe that's not a bad idea. If you don't mind, we could probably just throw Tracy right on stage because it's actually a pretty good segue from
just
what you're
throw
doing.
him out there. Yes.
Throw him out there. Toss that poor man out into the fire. Not a problem at all. Tracy, if you don't mind, we could probably send you out into the field to show off your chops. Where NeuVector actually picks up from what Ray was doing. And in case the audience didn't see what he was doing, it's really powerful. We modeled the proper security profile for a given application and groups of pods and cluster and containers, and deployed that security posture with a brand new Kubernetes installation via Rancher, so that when the apps land there, the environment is secure already. We didn't have to wait. So Tracy will show you how we're able to exercise those apps and do that inside of NeuVector, starting right about now. Thank you, Tracy.
Right about now. Hi, everyone. Let's get the PowerPoint. There's going to be a couple of PowerPoint slides, but the majority of this we're going to be spending time in here. The live demo that I'm going to be doing is really scary. My hands are sweating. I've done this demo a number of times. It has never gone the same way twice. So you're in for a treat, right? We're gonna keep it exciting. I will explain a little bit about NeuVector, and I'll cover some of the capabilities. So I'll do kind of a very brief overview. We'll use that. But I kind of want to start out talking a little bit philosophical. NeuVector is part of what's called Repo One. This is the U.S. Department of Defense. It's a centralized container resource headed up by the U.S. Air Force. So the chief security officer for the Air Force is basically heading up a group that is establishing best practices around building software, using DevOps culture, using iterative and agile processes, containers, and best practices around all of those kind of things. So they created a repository of pre-approved images, and NeuVector is in that repository. This is a very new, this has been going on maybe for a year and a half-ish, but still fairly new, especially when you think about government agencies and stuff like that. The reason why I'm opening up with this particular topic is a couple of weeks ago, we did a presentation along with some others. It was called an Ask Me Anything. In fact, I will just hit return on my chat window. Don't go there yet. Don't go there yet. Don't surf yet. But this, basically, they do an Ask Me Anything kind of questionnaire thing. And so you can watch 5 presentations by security vendors. I know you can't wait. But you can see us, Aqua, Prisma, StackRox, et cetera, doing presentations to a group of about 500 people who attended this session. And the reason why I'm bringing this up is because the Air Force Chief Software Officer, Nicholas Chilean, he had this slide. And when I saw this he was kind of explaining what they're doing, what's part of this process, how they're securing, how they're making this available, how they're going to speed up other government agencies and DoD to deploy secure applications and containers and Kubernetes, et cetera, et cetera. He came to this slide. And if you notice this very top line here, 2 scanning solutions are mandated. That's required, right? That's not, we're asking you to, that's mandated. They do that. They scan with 2 different scanners because they find that the results are different between scanners, right? They get false positives, they get false negatives. Some scanners don't pick things up, et cetera, et cetera. And it really went to the point of that it's a difficult thing to scan whether you're scanning code, whether you're scanning images, et cetera. It's a challenge. There are thousands of CVEs on all of these different platforms, right? And so when you see a list of all the CVEs that have been found in an environment, sometimes it's like, wow, you couldn't have missed anything. That's such a long list. But what we see in practice and what was highlighted in this presentation was that scanning images, that is but a layer. That's one thing that you should be doing. And you should probably be doing it with more than just one tool, right? You need basically some strategic overlap is the term between different tools and product. And I'm not advocating here that means you got to go out and buy multiple tools. What I'm advocating is you have to recognize the importance of security and layered security. So that was a big point. Also, the other big point that he brought up was behavioral detection. That being a critical layer of identifying the behavior of an application so that basically you can put a bubble around that, a zero trust bubble that says, well, if we know the known behaviors, all of the network connections, the processes that are running, then we can also identify what's not that behavior, right? Because sometimes it is just a bubble, right? Just because of an anomalous network connection happens doesn't mean you've been attacked or you're being hacked. But it's definitely something you want to check out, right? A majority of these are processes and applications that are doing their thing, right? So detecting something anomalous is the key. Getting the information is the most important thing. Not getting the information means that you can't check it out, you can't evaluate it, you can't determine that it is or isn't something good or bad. You just don't even know about it. And so knowing and getting that information, that's a big cornerstone for security, right? Yes, we lock our doors, but in some environments, you also have security cameras that are watching that door. We know that it was locked, but we trust and verify. So I wanted to bring up this point because what I'm about to show you is what happens when say you missed a scan. One of the scanners missed something. Let's just pretend that the CVE doesn't exist or hasn't been identified. The other point I do want to make, and I'm probably jumping all over my future slides. We know software is not perfect. Duh. I'm not making any big statement here. Security tools are also not perfect. And as a security vendor and sitting through lots of security vendor pitches of competition and, et cetera, et cetera, there's there's a lot of marketing and sales involved in security tools, right? They tend to say, we will protect you from the bad things and only we can protect you and all that. And we get a lot of feedback from security professionals at lots of different companies of, they understand, they really get sensitive about these grandiose claims of how we can detect everything. So the point of the demo that I'm going to do today is that layered security is extremely important, and getting information that you can investigate is extremely important because security tools aren't perfect. One attack may be easy to identify. A very similar attack that has been adjusted or tweaked just a little bit may actually be very difficult or impossible to identify, and you may need other ways of seeing that there's activity happening in that environment. So that's what we're going to kind of focus on as far as that goes. We also see a lot of companies talking about that, you just want to buy one tool, or even when we talk to certain prospective customers, they may be like, look, we just want one tool. They're buying security the way they buy insurance, right, for their home or car. I just want the most coverage for the least amount of cost. I don't want to have multiple insurance companies. That would be foolish, right? One security tool and the expectation that one single security tool is going to protect you from everything, that's not going to work out really well for you. You need to understand layered security. Strategic overlap, a term I mentioned earlier. This is a good thing to have sometimes. You want to have overlap between different capabilities, maybe between tools or whatever, because you don't want to have just one source of truth. Everybody claims to have a source of truth. You need to be questioning where they're getting this information. How are you arriving at identifying a network connection or a process? Where are you learning that? How are you seeing that? How can I trust that? Because the reality is in security, nobody really trusts anything, right? Security professionals live by the trust but verify, whatever that's called, label, can't think of the right word for it, but you know what I'm saying. They live by the trust but verify approach and belief and policy, whatever you want to call. So even like I had a fantastic discussion with a developer here in Denver who was talking about Kubernetes network security policies that, I have locked this thing down. There is no way anything can happen inside this cluster because I have defined everything and I have locked everything down. And we were kind of going back and forth how, layer 3 and layer 4 versus layer 7 and kind of getting into technical details. And I finally just kind of bubbled back up from the argument or the conversation and I basically said, so how are you verifying that? You locked the doors and you say that there is no way anybody can get in. Are you also checking the windows? How do you know? Do you have security cameras verifying that nobody can get in, that no other activity is happening? Do you have a backup to this claim that you have locked it down? Because it seems like you would want to make that claim and then verify. And I know this to be true because we have these tools that are showing us that you can't get in any other way, et cetera. So layered security, very, very important. There is a lot to get into about NeuVector. Basically, we have two different components. I'm not going to talk much about the scanning component. I'm going to cover that very, very quickly because we do scan for vulnerabilities. We do scan for CIS benchmarks and security settings and things like that. And I just want to I'll just quickly, NeuVector scans the underlying platform. So we do scan Kubernetes, Rancher, OpenShift for any compliance checks, CIS compliance checks. I don't have any here because I'm in a fairly recent deployed Kubernetes with no known vulnerabilities. I'm sure there's some in there, but we just don't know about them yet. We do scan the worker nodes underneath. Again, same thing for compliance, vulnerabilities. So these are the VMs that are running underneath your Kubernetes cluster. We scan the containers as you would expect. We scan them when they're running live, like you can see right here. So we're able to ingest those images, do the scanning. We also do layered scanning in registries. So if I go to the details of this particular registry and click on one of these, You'll see evidence of our layered scanning. We're showing all the layers where all those vulnerabilities exist in this particular image. We can show the Docker command that was used to create that particular layer. We have links to the source of these CVEs and things like that. So lots of information about what may be vulnerabilities that exist in the environment. But let's just assume for a minute that we have a vulnerability on a particular container, and I know we do because I put it there, and I made sure that it was vulnerable. What happens in the case where the scanning doesn't catch that, right? Let's assume for a moment, and this is where we'll go into my favorite analogy of understanding the perspective between scanning and runtime security, right? Everybody who has a car, if you checked, I think you probably have a rearview mirror in that car. It's something we kind of take for granted. If you rented a car and it didn't have a rearview mirror, it just had a little sticky spot where it used to be, you would probably go back to the office and say, "Hey, I've got a bum car. You're gonna have to set me up with another one, right?" It needs to have the mirror. It's worth going back to the office and getting another car. It is important. We know that's important, but it is a historical perspective, right? All the vulnerabilities that exist in your environments today that don't have CVEs, haven't been identified. The CVE has to be identified, then they have to fix it, then you have to find it in your environment, then you have to fix it, right? So there's multiple steps to this IT debt of vulnerability scanning and remediation, and that's why there's so much automation built around that. It's extremely important. If you know there's a hole in the dam, you better plug that hole. So critically important, but sometimes you need something more real time. You need other sources of information to tell you what's going on in the environment. And that's your eyes on the road, right? That's looking at network processes. That's network traffic, looking at system processes, seeing if there's a way to see if there's anything anomalous or unknown. Making that part, that runtime part, that is extremely important. That is what we're going to demonstrate today. So let me explain a little bit about how NeuVector does this, and then we will get to that. We use this diagram. Gartner did a nice technical report about a year ago, April of 2020, talking about different container attacks and how to control them. And in that particular technical document, they talk about these risk-based controls. NeuVector certainly does some of the scanning, CIS benchmarks, some of the foundational basic things that everyone should be doing. But when you get to these risk-based controls, where we're talking about layer 7 segmentation or behavior-based controls, that's what we're talking about here. And so that's what I'm going to explain that we do. So our runtime inspection, the way this works, inside of Kubernetes, you have this explosion of east-west traffic, right? You have container to container, pod to pod communication happening. And lots of companies like to talk about visibility in these environments. But what they're really giving you is really kind of a representation of either the YAML manifests that defined what the network connection should be. They may be using kernel shims or eBPF to filter out all of the send and receive calls made at the system level, the system calls. There's only 2 that are related to network traffic, and that is send and receive, plus IP tables, maybe some port labels. And they'll put all that together and say, hey, this is your network. This is what it's doing, right? No, I mean, that's maybe what you have set up, but that's not telling you live traffic. They're not looking at the live network traffic. And that's pretty critical, because when we're talking about sources of truth, the best source of truth for network traffic is network traffic. It's why we have firewalls on the perimeter. It's always been kind of that first point. If you can't get into the environment, you're stopped at the front gate. And that's exactly, and of course, you may have great perimeter security with those firewalls. You may have great visibility for your ingresses and egresses. But once you get inside these clusters, then basically that's what Rancher and Kubernetes do. They take away the complexity of running all of these ephemeral containerized environments, right? You still need to be able to see what's going on. And so that is what NeuVector brings to the table. We are able to inspect that network traffic. We can do this at layer 7, which means we can not only identify the layer 7 application protocol, we can also validate it, which is really critical when you start thinking of like tunneling attacks. That if we can see a tunneling attack or see some kind of script injection or something like that, we can immediately identify that and then possibly even block or at least monitor, at least alert you on it or block that if you so choose. This is patented the way we do this. This is one of our 6 patents. Not only do we learn all of the network activity, we also learn the processes that are happening in this. And so that's what Ray and that's what we've been kind of talking about up until now is using the behavior to identify network and processes that we have good sources of truth for identifying those that we can trust and that will give us the best information that's actionable and accurate, right? You need accurate information so that you can take action on it and know why you're taking those actions. So that capability of being able to build those security policies means, as Ray was just showing you, we can do real security as code. We can export those policies into a YAML file and we can apply them to other clusters because we know that behavior. We can carry that zero trust bubble to other clusters so that you can identify something that doesn't match the behavior that you had seen previously in lower level clusters like dev, QA, staging, et cetera. Because we see the actual network traffic, that means we can also do countermeasures like packet capture. We can automatically packet capture if we identify a particular threat, or if you see a threat in monitor mode and you want to quarantine a container, you can do that. You can do an active packet capture. You can move that container from monitor mode to protect mode. I'll talk about the modes here in a moment, but you have available numerous countermeasures that you can take action on when you see a threat. And a threat could be a 0-day. It could be an unknown CVE. It could be one that your scanner didn't pick up, or maybe one that just the developers didn't have time to get to. Or the most realistic situations are when you have libraries that have dependencies on those libraries as to the way your application functions. And to make that update from, say, Python 2 to Python 3 means really kind of more of a rip and replace, making it work with the newer versions, right? So we've seen that many, many times. So, and because we can automate it, so we can automate the learning, we can automate the export of that learning into those policies and then apply them in other clusters. That means that we can now move our security at the same pace as our SDLC. So if you're a DevOps culture and you're using some automation tools like Jenkins and Circle CI, et cetera, yes, we can make that much easier as part of that, as we've seen with like our Circle CI orb. So let's talk. I got to talk a little bit about the architecture so that you kind of understand what you're seeing and why you're seeing it. I'll talk about the operational modes and then we get to see this thing in action. So if you are familiar with things like service mesh architectures with a sidecar, you saw on the Nicholas Chilean's, the sidecar architecture. A lot of people are familiar with the sidecar architecture. Istio uses it, things like that. We do not use a sidecar. We don't use agents. We don't use code changes to detect what's going on. NeuVector deploys as a container set. We have 4 different kinds of containers. The controller is the brains of NeuVector. This is where we're managing all our API calls. Everything in NeuVector that you see in the web UI is made via API calls. So 100% API coverage. The controller is the brains, and that's all we need to talk about that. Our scanner, very fast, proprietary built, created with 2 goals, accuracy and speed. And we have customers with image repositories with over 100,000 images that have struggled in the past before they acquired NeuVector to scan those very large repositories. So we can, not only is our scanner very fast at a container level, but we can also scale that horizontally to scan very, very large image repositories. The web UI, as I mentioned, full API access there, also provides a CLI console. And finally, the most important and the one that does make the difference between NeuVector and every other security product out there. This enforcer. So this is where we see the traffic. This is where we're able to enforce those security policies. You can see here deploys as a daemon set. That's optional. 99% of our customers do deploy as a daemon set because, again, they trust the information they're getting from NeuVector. And they also lack the capability of being able to, when they see a root bash into a container, they like to be able to know that that's really root, not just somebody who acquired some credentials. If they need to block that activity, they can. We can actually block root and processes and things like that. So with that, I'm going to explain our operational modes because this is critical to understanding what you're about to see in NeuVector. The Discover mode is 100% automatic. There's no configuration. When you apply the license, we just immediately begin learning everything. So you'll see some blue lines where we're learning some natural behavior. We're going to learn the behavior of an application. I'm going to click around on the website. We're going to learn that behavior. Then we're going to switch to monitor mode. And then we're going to attack the exploit that's running in that container and see what we see there. We're going to attack it a couple of different ways. And then I'll move it to protect mode. We will repeat this. This attack when we're in protect mode so that you can see what happens at that level. We're going to use, let's just move to how we're going to do this as my hands start to get sweaty because it's always fun when it's a live demo, right? So like I said, we're going to learn some application behavior in Discover mode. I'll show you what that looks like. Then we're going to move it to monitor mode. I'm going to use a couple of different exploits. So it's a fairly old exploit with struts. And I actually found multiple ways of attacking this particular exploit, and which is really interesting because as I was preparing for this, I actually found one way that we didn't detect it natively the way we detect kind of the first approach. So I'm actually going to show you when our product doesn't detect a particular exploit natively. It's a more advanced approach, but it is one that is out there open on the web. But you're going to see how we don't detect that it's a specific threat, but we do detect that the activity is there. So you do get visibility that someone is doing something and that they can be blocked. So that's kind of what we're going to show. So with that, without further ado, let's go to first our network activity screen. So what you're seeing here, and I see we've already got some lines here. So what I'm going to do is I'm actually going to delete a lot of this activity. So these lines that you're seeing here, this is activity. When I was talking about the blue, the monitor mode, and protect mode, these containers right here are in a monitor mode. So I'm in monitor mode, which means we're not learning any behavior. The containers that you see over here with the blue lines, that is activity that was learned while in monitor mode. So we see that activity. Then once we've exercised the application, we kind of flip that off and turn on the monitor mode so we can see anything that wasn't that learned behavior. So what I'm going to demonstrate, and I apologize for not having these cleared, but this is when we do testing, this is what happens. So I'm going to clear all of this behavior, and you can see all of these lines of unknown behavior here. And the reason is so that you can actually see this happening live during the runtime. So I'm going to clear all of those lines, all that behavior, and I'm left with my cube strut pod right there. That's the one we're actually going to be attacking. So let's now go to our groups, and I'm going to filter down to, there we go. And this is the container. So just to validate, you see no process rules, you see no network rules. We've learned nothing about this container. It was just sitting there. I've deleted everything that was happening before. I'm going to select this, and I'm going to switch the mode to Discover. And excellent. So now we're in Discover mode. We're going to learn some behavior. So I happen to have this struts. We're running the basic website that runs on this particular container. So I'm going to refresh this. Let's click on some things. I'm looking at order 3, looking at order 4. Let's create a new order. I'm going to call this Jorn and I'm going to give it 55 and an amount. That's not how much he got on his Grubhub promo today. So we've got Jorn there.
I'm hungry though, so thanks for thinking of me, man.
Yeah, you know what? Let's just go ahead and delete that.
Man.
We'll delete that. Yes, we're editing, we're viewing, we're doing things. Let's change Tracy to 88 because he is hungry. And if I created, well, we've already done the create the new order. So we've been exercising the app, right? We're calling different functions within the app. Let's go back to NeuVector and let's do a refresh on this. All right, we've got some network rules showing up. We've learned that we've got some network activity. If I go back to my network activity, you can see we've got some HTTP traffic that we just saw. So that looks like normal traffic because I was just doing normal things. So we're starting to immediately see that traffic. Let's do one more thing. I'm going to bash into that particular container because I want to make sure that we can see some process learning as well. So I'm in this container. Let me do a who am I? I am root and ls minus al. I see things. Let's move to the temp directory. Minus al. Excellent. So we're seeing things. And I could probably, I'm doing some cd commands. I'm trying to think of some other, let's do nc. There we go. We got an nc. So I'm doing some things in here. Let's go back to our policy groups and see if we actually learned anything in that discover mode. So I go to process profile rules. Well, there's our bash. We just did that at 10:39, minute and a half ago. We also saw some Java. So this is when the application itself was running. We saw Java being ran. You saw me do a who am I. You saw me do an ls. Right. So we're seeing actual process run on this particular container. You also notice you saw that TCP 8080 right there. You may have seen that I bashed into that container. So we saw that as well. So now we're going to switch this to a monitor mode, which means we're not going to learn anymore. We're going to switch that mode. And now let's go back to where we were running these. I need another, let's see.
Like a wget, go out to the internet with, example.com.
Curl,
example.com, yeah.
There we go. Oh, curl is not on here, wget. Excellent. So we did some wget there. All right, now let's go back to our process profile rules. I'm going to hit refresh here. We didn't learn those. No, because we're in monitor mode. We don't learn in monitor mode. So what does that mean? Well, if I go to security events, hold music plays in the background. Here we see so there's my wget. So you're getting alerts. Right? We didn't say that wget was bad. We just said we hadn't seen it before. So you're immediately getting alerts. You're getting things like, well, the process bash wget was done by root, et cetera, et cetera, et cetera. Right? So we're in a monitor mode. And you'll see here that this is implicit deny rule or process profile rule. So that just means that there wasn't a rule there. There's an implicit deny at the bottom of our list for network connectivity as well as process activity, right? So we're learning what's going on here. All right, well, let's attack that thing. This is where the fun begins. And I'll have to bring up one more window because I do have multiple commands to execute here. So like I said, found a couple of different Python scripts that take advantage of this particular struts vulnerability. And the first command that I'm going to run, so let's cdnv, go. So I'm in the right directory. And I've got a couple of different struts Python attacks. I obfuscated this one. You won't find that one on the internet. There is another one that you can do, this strutspwn.py. You can find different attacks. Be careful when you're surfing the net out there. So the very first thing is I'm going to run this one right here because it actually gave me a pretty nice way. This is how... This is kind of how it works. We're going to run a command that's going to see if the vulnerability even exist, because I can run this against basically any website. Basically, I pass in the website HTTP address, which is that 115.176. You see here 115.176 appear at the top. And so when that comes back, that will say, yay, it's vulnerable. We can do things with that. Yay. So I'll come back to that particular script. I'm going to run this struts2 Python, and I'm going to try to do a reverse shell. There is a command that you can use using netcat, fairly well documented. At least I found it out there, where you can actually do a reverse shell. I'm not going to set up a listener on this particular container because it'll show, I've got connectivity and access. But to kind of speed things along, I'm just setting a port here and going to try to run that. And remember, we're in monitor mode. So I'm going to hit return on that. And you can see we got some errors. And what this tells me, when I get up here at the top, you can see this doc type. So we did get a response. I hit that container. I did get a response. Now, yes, I did get some Java errors, et cetera here, but I got something back, right? So that's vulnerable. That's, as a hacker, this is progress, right? I've got something that'll send me a response. should continue in with this. Now, something obviously is not working. It's causing some kind of stack trace here. Let's see what we see in NeuVector. Interesting. So 33 seconds ago, we saw an Apache Struts remote code execution. We see that as a critical threat. So NeuVector detected that this is taking advantage of a particular vulnerability that we know of when someone tries to do this remote code execution. And you'll also notice down here, 33 seconds ago, 39, 40 seconds ago. See that command NC? We also caught that they were trying to do a shell. They were trying to run netcat. So all of that information was there. I could review rules on this to say, well, do we need an NC? Maybe I should allow that to happen. I don't know. Probably worth a discussion. But this right here, these critical alerts, that is definitely worth looking into. In fact, here you can even see we do an automatic packet capture on that. So we can take a look and put this in a PCAP, look at it in Wireshark to do some analysis of exactly what's going on there. Well, that's interesting. We detected that. Let's go back and try something else. All right, so let's clear. And now I'm going to run a little bit different exploit using this struts pwn. I'm going to try to do the exact same reverse shell, and then I'm going to try something else as well. So here you see we're trying to set up this reverse shell. Pay attention to this port right there, 1337, which in hacker terms is LEET. So I'm going to try this one now. Exact same thing. Now, this Python script is a little bit more advanced. This is the one that we used earlier to detect if there was a vulnerability. This one is definitely more advanced. I'm going to go back to here and do a quick refresh. More hold music. Interesting. So just now, we're seeing a process profile rule on NC, which we saw that earlier. But notice I'm not showing this Apache Struts code execution. If I hit refresh, because this particular Python script works just a little bit different. So we're seeing now, well, we've got that NC that we're seeing that process was attempted to be executed. Let's go to look at our network activity screen. Now, what we're seeing here, you'll notice that we had the blue lines before, but now we have some red lines. So this red line here, this is that, that's such a wonderful feature to be able to stretch that window. So you see here, we saw that remote execution, that we saw that as a threat. But we also saw possibly, when I see here this going to an external network, see that TCP 1337? We saw that connection being made there. We see the connection being attempted there. So that's interesting. Do I recognize that? I've got now some information I should probably check out. I think between that one, I think we saw the HTTP, et cetera. So we're seeing the network traffic there. Let's go back to our security risks one more time, or sorry, notifications under these events.
Well, I'll add one comment here. The reason he's having to run Python scripts to exercise this is because the way the attack's happening is against content headers in the payload request. So if you really think about tools that maybe try to find the path in the Java code, right? Is this vulnerability even used? Well, it doesn't have to be used because it's actually part of an exception. So the fact that we can see it from the network activity and the process activity within NeuVector is incredible, because there's no other tool on the developer side that's going to give them a for sure this thing isn't used. This gives you that view into the actual attack itself.
Trust but verify. Well said, Maury. Absolutely. So now what should we do? We've seen this. I'm very suspicious of this, even though, below, when I was using kind of a basic approach, we caught that. But now I'm using a more advanced approach that maybe is obfuscating, or is not obfuscating. It's getting around our remote code detection, right? Security tools are not perfect, right? You need security in layers. So when we see this, maybe my reaction to this is I'm going to go to that particular container. So here we go. That one right there. Now, again, I'm going to check my process. So this is what I have here. Network rules, etc. So everything's the same. I'm going to switch that mode now to protect. So here we should be alerting and blocking. We've learned those. Now let's go back and let's repeat the attacks that we tried. So I'll go back to this one right here using the struts2.py. Now remember how that came back immediately and said, all this Java stuff, all the everything that was going there, that's probably going to sit there for just a little while. Let's see if NeuVector is doing anything with that. Let's hope NeuVector is doing something with that. There it goes. Apache critical deny. So again, did an active packet capture. We basically stopped it there. Notice also that there is there's no process deny, right? We stopped it at the network level. When we went down here, so that we had the process profile rule violation by NC and SH, right? That all came together. But you don't see that this time because it got blocked at the network layer. The front gate was locked. We didn't even have to get to those other layers. We stopped it immediately. We did a packet capture of that immediately. All right. If their security guys are going to be smart about that, I'll get smart about that too. So yeah, we got our timeout. We didn't get the exact same response as we got earlier, right? All right, well, let's try the more advanced approach to that. The one that can't be detected that way, right? So we'll give that a moment to work. Let's do a refresh here. Because if they can't detect it at the network, I must be golden. I'm in. I see now, just now, process profile rule violation by NC on that container. And I got another implicit. This is see that 34214.159? See that TCP port? We denied that. So we denied running that command and setting up that reverse shell. And here we did that at the process level because somehow they got through the network layer. Right. So the network didn't discover that, but using a more advanced exploit, I did get stopped at the process, and as well as this network connection was denied. So never mind the command, even if the command had been whitelisted and we had added that to there, that network connection going back to this IP address on that port, no, that's not happening. So again, we had a middle gate that it's at the process. And then we also had the back gate. The back door was also locked so that they couldn't egress from that. So that really is how we do the behavioral learning. That's why that runtime behavioral learning is so critical, because you're learning everything at a process network level. We can also add file access level. We could protect a directory. And instead of running those NC commands, I could run touch commands or remove commands or anything commands. So all of those commands become very important. File locations become important. We don't learn the file changes automatically. Those are more risk-based. You would have to add that layer on yourself. But that's essentially how NeuVector works. I will take questions now.
So just to be clear, Tracy, had we gone and exercised our app, known what was supposed to be done, and put it in a protect mode, that was really the ace move, rather than wait around for something.
That's I think you bring up a good point. Every environment is different.
Yeah.
Every application has a unique risk profile, right? You give the same requirements to two different groups of developers, you're going to get two different applications. Yeah. Yeah, exactly.
You ask two people, you get 6 answers.
You're going to get 2 projects delayed for months and months. No. So yeah, every application is different. And again, to stress, the information is the most important. Yes, we have customers whose goal is to be 100% in protect mode. We have other customers who want to be 100% in monitor mode and use protect as a countermeasure, as a thing that they can do to counteract this. The fact that we capture those packets automatically, but you can do that here as well. So when I'm here, if I'm seeing this activity coming from these different pods, right, I can right click on here and let's just do packet capture while this thing is running, right? So I can do an active packet capture for 10 minutes, 2 minutes, et cetera, et cetera. We set a limit on that so that you can see exactly what's going on. So these are you can also, maybe I don't want to allow anything to happen there and I'm just going to quarantine that container. We won't kill it, but we're going to block any network activity to it. So you have multiple things that you can take action on when you see something anomalous. But the most common thing that's happening is, and you can even see here this little X when we block that traffic right there. So there's the denial. And that's the difference between the deny mode, the protect mode, and the alert mode. So again, it's how you want to use the tool. It's how you want to assess your risks and where you want to put the emphasis for monitoring that information, things like that. And the key is accurate sources of information, questioning what those sources of information are so that you can take action and make that data actionable.
Fun.
Any questions from our groups? I know we're going to move into individual areas and all of that, but happy to show more, try different exploits, whatever the case may be. We may adjust some of these exploits and see what we can get away with later.
Awesome, sir. Well, I'm going to take away.
I don't even have I'm done slide. I
don't even have a goodbye screen.
that's where the presentation dropped right off a cliff.
Right.
Like, all right, there you go.
Yeah, what you fail to account for is that your demonstration actually worked. You had no contingencies for not needing a contingency.
No, there was no contingency. That is true.
So that wraps it. Oh, look, there are questions. I was about to say nothing's in the QA box, and I jinxed it. You don't need me to read these to you. Can you see the box?
I can. So this traffic behavioral approach is this, and how is this different than the runtime scanning you offer? Right. Oh, great question. So the scanning, the runtime scanning. So that's also checking for vulnerabilities. That's checking for compliance checks. You're checking Kubernetes settings, the Rancher settings to make sure everything meets, CIS benchmarks, of this is what should be done. These are the best practices and things like that. So the scanning for the image is different than the runtime, right? The runtime, that's where we're using that enforcer to see the network traffic. We're also using some Linux native processes to capture any process that gets run, any parameters that are passed to those processes. So we can see all of that information and we're able to, that's the runtime protection. Now, some companies will say they have runtime protection, runtime, visibility. These are all kind of buzzwords, if you will. So those are things you have to really ask about. And that's a great question. asking about the runtime protection, yes, we're seeing this live. We're seeing it as it happens. And as you can see, we can quickly block and take action on that kind of runtime. So runtime security is a little bit different than what I would say like runtime scanning. Runtime scanning is maybe scanning the images that are in an environment that's live, but they're not looking at actual traffic. They maybe not capturing processes. There are some products that do capture processes and can block processes, but they can't combine that with the network behavior learning. And frankly, if they really trusted that process blocking, they would give you the ability to export those as rules and apply them to other clusters. NeuVector is the only product that can do that, right? Mm-hmm. We trust those sources of truth. We know the accuracy of those sources. And so we trust that we can test those and validate them and use them in other environments. We know how to build that zero trust.
So next question, and I'll read it to you because I'm going to shut off my little share because you're going to want to go back to the interface. Because I know this is another new question for NeuVector, and it's a tough one. It's Lindsay coming at you going, how do you keep that network activity tab from being overcluttered and noisy and making your teeth hurt?
Come at me,
like
bro.
A bajillion things.
Come at me, bro. Hi, Lindsay. Great question. So we have been updating, and there's big updates coming for this network activities side. Basically, filter down. So this obviously is a very simplistic, very small environment. We have customers with lots and lots of containers, hundreds of containers. So this screen can get really messy really quick.
Turn on your system containers and turn on everything in your view. Maybe show everybody.
There we go.
Everybody else, like you can fill up your screen with stuff.
Yeah, we have pictures of just boxes and blue lines, and it just looks horrifying. We're not trying to scare anybody, but the best way to do it would be like if I want to, as you see, as I start typing, all the different ways you can filter down. So, for example, if I was just looking for that one container, I would type struts, and I can see I can filter down to a particular group here. I can add additional, and then you click this little checkbox, and it'll filter right down. So hopefully that will help you filter down quickly and get to the information you need. And like I said, there's some new enhancements coming to actually help with that. We're going to be using, I think, some new libraries and things underneath to make this very fast and much more user-friendly from that standpoint. Lindsay, if you have some advice or if you have some requests around that, definitely feel free to shoot them our way.
All right. You said, come at me. Here's one for you, and I'll read this one out loud so the audience can hear it. This one comes from Nils, and he says, especially in a production environment, because that's where we care, how are you providing privacy and data protection? So how are we not tripping over a privacy problem when there's also packet capturing going on? You know, what if there's PII at the same time? How can you be both good and because yes, I definitely get this question. So because we're able to see that network traffic, and let me clear that off. So since we're able to see all that network traffic, we can also inspect the payload of that traffic. So we have data loss prevention sensors. Yes, they are regex patterns, but we are doing regex against that actual network traffic. So you would apply a DLP sensor. So if I go to a group, and I think I do have a demo. Yeah, I've got a demo cluster here. So you could do this at a namespace level. You could do this for a group. It's better as a group. Again, you have flexibility of how you create these different bubbles, right? You could have a bubble for each namespace. Then you can actually create a custom group that includes multiple parts of your applications or services or whatever. And then down here, when you select that group, you can apply a DLP sensor to that group. So all the traffic inside is fine. But if any egress leaves with a social security number or credit card number or government ID or secrets, anything that you can build a regex for, we will detect that and we can block that. Pretty easy to test. If you're in a financial services company with SOC 2 compliance and you're moving to containers, a quick heads up, we have some new recent customers that needed SOC 2 compliance for data loss prevention in containerized environments.
And NeuVector was the only product that was able to accomplish that and help them pass those regulatory audits. So if you're looking, so to answer that, Niels, you can do this if you're in Australia. They have strict data egress protection. No data should leave the country. That DLP can help you achieve that.
Well, and on the other side of the coin, just make sure we're hitting Neil's question correctly as well, is NeuVector doesn't actually capture or doesn't store that data. If you're doing a packet capture as an end user, you have to explicitly put that somewhere, but none of this stuff gets written back to a database. Any data that NeuVector does exchange with its own elements is all encrypted, but none of that even writes to a database locally. And NeuVector doesn't even speak out to the internet unless you explicitly tell it to.
Exactly. Part of that DoD appeal, the reason we're in the Iron Bank and the reason we work with those government agencies is because we do run in air-gapped environments. There's no phone home, there's no SaaS product, and nothing bad about that. It's just that in those environments for these capabilities, yes, we can run in air-gapped environments and help with those kind of data sovereignty requirements. Excellent.
All right, I'm gonna kick you out of there because we've actually got breakout rooms for each individual kind of company if people want to join them. Young, thank you for posting those there in the chat if somebody wants to hit those URLs. So all of us will be heading off that direction. But before we go, on top of the thank you for showing up, we hope that this was valuable. Really want to remind you that we are going to be drawing a couple of winners for both a $50 Amazon gift card and a $100 Amazon gift card for those people who stuck around through the whole darn thing. Ooh. Young, did I get that right? Nobody's winning a new car.
Yes, you did.
No new cars, but Amazon gift cards, which don't expire. You can just apply them. So if you have any questions, obviously we're going to be getting out the recording. We're going to pull it back, edit it, post it. If you want presentation materials or anything, reach out to us here at NeuVector or reply back to that email that you got for the invite. With that being said, unless anybody protests, I am going to shut this particular meeting down, and I and Tracy are going to head off to the NeuVector breakouts. If anybody wants to join us there, we'll be there for just a few minutes because we have to get back to our day jobs, protecting the universe. And thank you. This felt like a success. We'll see you all on the next one.